Hi guys, Miss Andronicus again. Today we're looking at solving one-step equations with algebra, and these are just addition and subtraction. Let's go over some rules. These rules apply with any algebraic equation solving that we're going to be doing. These are the ultimate goals. Now, we've got x must be alone, and when I say x, I mean really any variable that they use. It always must be alone on its side of the equals. X must always be positive, and what you do to one side, you must always do to the other. So keeping those rules in mind, let's try a few. So here we have x plus 7 equals 12. Now for communication, it's very important that we have every step of our working along the way. So here we've got x. Now, according to our rules, it needs to be alone on its side. So this side of the equals. It is not alone. So in order to get rid of a positive 7, we must do the opposite and subtract 7. So I'm going to write it very small underneath there. And the other golden rule that we had from the start of this lesson was what you do on one side, you must do to the other. So you need to make sure that you have it on both sides. That way, you've cancelled out on here. All you've got left is your x, and I'm going to write it there so I can line my equal signs up nice and neatly. And then it's just simply 12 takes 7. 12 takes 7, we actually calculate that, which equals 5. It's really important that we get a different colour and we do a little bit of a check to make sure that we are on the right track. So we used the original question that we started with. We calculated that x equals 5. So instead of putting x, I'm going to put 5 plus 7. And I'm actually going to do that calculation. 5 plus 7, I know equals 12. Is that what I was started with originally? Yes, it is. So I know I can give that a tick. Okay, example number 2. Here we have y and we have a negative 5 with it. So negative 5 plus y. We need to cancel that negative 5 by making a positive 5. What you do on one side, you must do to the other. Cancel it off this side. Only y is left, and we have 6 plus 5 is 11. Again, you make sure you do check. So then you have negative 5 plus 11. What we can substitute that 11 in for y now. And we actually do that calculation and we know that equals 6. Yes, that's what the question originally asked. Say, for example, you had y equaling 10, then you know negative 5 plus 10 would not equal 6. Therefore, those numbers would not match up and we would need to then re-look at our work to check where we've gone wrong. Okay, a couple more examples. We've got f over this side now. That's okay. We need to keep it on this side. So we want it to be alone, whichever side it's on. So to get rid of this 16, we've got a plus 16 on both sides because what we do to one side, we do to the other. Cancel it off. F stays on that side, which is not a problem. We still line our equal signs up. We don't want to go switching the sides. If it's on the right, keep it on the right. And then we have negative 11 plus 16. That's going to be 5. With our check, it works a tiny bit differently because we can't start with the negative 11. That's the answer. We're going to start with wherever f is. So we're going to start with this side in our check. If we've said f equals 5, we're going to start with 5 take 16, and we're going to check what that equals. That we can see equals negative 11. Are we correct? Yes, we are. So the checks work slightly differently for the other side. Example number 4, final example, we've got, again, g is over this side. We want it to be alone. We need to cancel out this positive 10 to make it subtract 10. That's how we do it. Only g is left on this side, and we've got 7 subtract 10. That goes into our negative 3. Now, I know I said I always want g or the variable to be positive. Well, technically, the variable on this side is positive. This is the other side. It could equal whatever over there. As long as we don't have like a negative directly in front of the g on this side, then the g is positive. Really quick, we can do that check. So 10 plus negative 3 Technically, we know the negative will always override that, so 10 take 3 equals 7. Is that what we started with? Yes, it is. And that is solving algebraic equation one step with addition and subtraction. Thanks. Ciao for now.